Hello, so for a wave, the wave speed is given by this formula, v is equals to f lambda. But why? Actually, it's very straightforward, because the wave crest always advances by 1 lambda in one period. You don't believe me? You look here. Huh? So this is one period. So in this one period, the wave crest travels 1 lambda. So 1 period, 1 lambda. That's why the wave speed is lambda divided by t, which is f lambda. The wave speed is usually determined by the medium. So waves of different frequencies must still travel at the same speed in the same medium, which means if you have a higher frequency, you must have a shorter wavelength. So look here, this guy has twice the frequency as this guy. And because of that, he has half the wavelength of this guy. This so that they end up having the same speed. Yeah. So the black arrow is tracing the movement of the wave crest. And you can see that both of them have the same wave speed. And that's why, sounds of different frequencies all travel at the same speed. If they don't travel the same speed, music will be a very different thing, because as the orchestra plays, if the high-pitched sounds reach your ears before the low-pitched sounds, then, I don't know, music will be very different. Then some of you may ask, so what kind of medium will result in a fast wave speed? It's actually similar to the natural frequency of a simple harmonic motion. The stiffer the material, the lighter the inertia, then the faster the wave speed. So these two waves have the same frequency, but they have a different wave speed. This one has a faster wave speed because it has a longer wavelength. So this could be a wave traveling on a very tight, stiff metal wire. So the wave travels very fast and has a long wavelength. This one could be the wave traveling on a slinky. Yeah, it's heavier, it's also not as stiff, so the wave will travel at the lower speed on a slinky. Alright, that's all. Ta-ta!